Great. And thanks to the organizers. This has been great. ILSI has done a great job, and the committee did a great job of putting all this together. It's just been fast. This has been really a very interesting. Now, this is it? I should have practiced this beforehand, sorry.
The blue sticker
Thank you.
Isn't
this great? There's a box here telling me what to do. This is technology at its best. I'm going to give an overview, really. I'll give some of the work that I do, but I really also want to share an overview because there are other people working in this space. And I want to go over some of the different approaches to enhance dietary assessment with images. We have passive and we have active, and with passive, that's like a wearable camera, and I'll give an example of that. And users do not need to be engaged, that's in quotes. And lots of images are collected, and you need to detect those eating events. And the good side is those leftover images can be used for something else. And there could potentially be privacy issues, like we heard earlier today. And then there's active capture, and this uses usually mobile telephones, and it's better quality images, and the user is engaged. And is this big data? Yes, this is big data. And it's important to appreciate that because that when you see some of the progress that's been made, that it's come a long way. So one image for 5 seconds, you can get up to 400,000 images a day, and most of that is not related to food. So you have to filter through it. And then the active approach, you get 8 to 12 images a day, and that's because that's 4 to 6 eating occasions. Because you take a before and an after, and that with the video, you don't have to worry about that. Laced throughout these slides, I have some audience participation. And these are images taken from studies using the mobile food record. And so what I want you all to think in your head, how old is this participant that took images of their lunch? Shout out, yes? 5 years old. 5 years old. Did you see my slides? No, I have a 5-year-old son. There you go. Yeah, 5 years old. Wow, he is so good. What, you come up here. Okay, so then you can do the children. So now what guided me with my direction is there have been several reviews done on this topic, and there was one published in December 2015. And then we've extended that to December 2013 to January 2016, and that paper is right now in press, so that will be available. So this is sort of what's in that most recent paper has guided me with regard to covering what is the most current. And so these examples of using images for dietary assessment, we went through the active and we went through the passive, but there's also the difference between being image-assisted and image-based. So image-assisted would mean that you are using those images to assist with a 24-hour recall or a dietary record. So they are helping so that you have two enhancements occurring. And then if you follow down these different trees, then as you go down on your left side, that's a dietary record, and the enhancement was active capture of images and as well as passive capture. And then if we go back up and go down the 24-hour recall, the most recent example is being enhanced by passive. And then on the other side is image-based. This means that everything is images. That's all you're collecting, images. You're depending 100% on images, very similar to our last speaker. And just by default, that will always be a dietary record because it's basically a log of your what you've been eating. So I won't be covering all these because they're not children. And so I'll only be covering the parts of those that include the children since I'm children and youth section. So this one is, this is a image-assisted dietary record, active, and these images were captured with an iPad, with a tablet. And this was a study with children with, well, I think adolescents, excuse me, with intellectual and developmental disabilities, IDD. And fortuitously, the first author, she's on the program, so you'll hear from her later. And this is a very difficult audience, when you have some type of developmental disability, and it can be also an intellectual disability. And so they are not able to use the traditional methods. So what they usually depend upon then are 3 days of proxy-assisted dietary records. And so in this case, what they did, they had these proxy-assisted dietary records, and then the children, the young people, they took 3 days of images using the iPod, so they could be engaged in the process, which really will aid with trying to get all the images. And then what was really nice about this is that they had the 3 days of the proxy records. They did the analysis of energy and then the macronutrients. And when they added in the information from the images, the energy was 20% higher. So that does show that it can enhance. Now, they didn't compare with doubly labeled water, so this still could be underreporting, but the energy went in the right direction. And then another study is using very much the same idea of this, but they're using 100% the mobile phone, and this is just finishing up, and eventually we'll find out how these adolescents and young adults did with Down syndrome, capturing all of their eating occasions with using the mobile food record. So how old is this participant? Whoa, okay. 11. This person is 16. So wow, you're in the right place though. So I'm going to go over a little bit over the mobile food record, because it's one of many really that are people are working on that are active captures. So the individuals need to pop open an app, just like what we saw previously, and this is part of the technology-assisted dietary assessment program. And it's very simple. There are 2 buttons. It's before and after eating. What we discovered after testing is that usually when people sit down to eat, that is what they want to do. And so the faster you can make it for them and just have them do an image and get it out of the way, and then after they're finished eating, do the after image. And then there is this idea, when they go to take the image, there are red and green lines. And what's weird, we train very quickly. Humans train really fast. And so by the 3rd time, you can get that green lines by just putting it at the angle that you've been taught. And you can eventually turn it off because of that. But this is important because if you're going to do automated volume estimation, you have to have the right angle. Otherwise, it's very difficult to do with one image. So the thing with these type of methods as opposed to video is you only have one image, and that is a constrained problem for sure. So then the other part of this particular app, very similar to what you saw with the last app too, is that you can give the images back to the user and have them confirm the foods. And the way that comes back, this is a stylized image, is with these foods labeled with colored pens and bubbles. Now all the foods have to be shortened, or otherwise this whole screen would be full of the description of the foods. So in order to, when you confirm the foods though, then you see the full name. And so if you can look at this right off on the side, this pen right here is milk, and that's the first suggested food. So these foods you don't get just one food suggested, you get 4. The classifier goes through a number of iterations using color and texture, and so then the top 4 will get listed here, even though these right here, this is a case of these likely not being the right choice, but it does give you an appreciation of how color is a very important characteristic of food, because the ranch dressing, ice cream, and mayonnaise are not milk. But that's also to highlight to you how difficult this problem is, with color being a major characteristic and second being texture, and then contextual information. Now, this is really fun because we've had that top 4 for easily 6 years now, and imitation is the best form of flattery, I'll tell you that. I don't know if any of you saw this Mashable weight loss calorie app, Snap It, coming out September 30, and what they're showing off is that they can identify the food. Now, you have to put a single food item in there and have some like a little napkin underneath it. But what is really neat, look, they give you the top 4 that they think it is. Wow. Yeah, I know, 5. They didn't want to copy us exactly. Anyway, but I thought that was really neat to have someone copying this same idea. Then you probably have noticed in these images a checkerboard square. Also very important if you only have one image. And that is because if you're going to do automated identification and automated volume, you need to correct for the color. Every time you take an image, the color is different depending on the lighting in the room. And so this is the fiducial marker. It always looks bigger in the pictures. And then, so you can correct the color, you've got to get that scene looking the same way that it was when, it's be closest to the food. And then in addition, those squares, every distance here is known, and that's how you recreate the 3D environment in order to do volume. Now, so I'm going to move over now because these other 2 used adults, but I'll just move over to the image-based, and I'm going to go through an example that's active smartphone, and it's called the Food Record app, FRAP. And what I'll point out here is sometimes we want to start thinking when we develop these items as to who we're developing items for, and also how much we can capture. Do we need to burden the user? So in this case here, you can see there's a fiducial marker that was used in this study. Wait, I haven't shown you the fiducial marker. I have to go. This is the study here. But now I'll go to this is what the tool looks like. So this is the fiducial marker. And so it gives you size, but it won't help you with anything about depth of field and and also color. The other, and this came up in last session too, here's you take a picture, and then your next process is you need to select one of these eating occasions, breakfast, lunch, dinner, and snack. Your device is capturing real time, and real time is of more value than what a person describes their meal as. Now, if that's an important part of your intervention, you can show individuals 2 weeks of their images later, and they'll be able to tell you what meal was breakfast, lunch, and dinner, if that's important. But one of the ideas of all of these methods is keeping it simple for the user so that you can get days and days and full 24-hour worth of food. So now what I'm going to take you through is one using the mobile food record, and this is all in children 3 to 10 years old. And the way the scene went was the researcher demonstrated the MFR. They distributed one to the child. They gave them the fiducial marker and then this little wristband. The reason the wristband is because 3-year-olds and 4-year-olds don't really know the difference between right and left. And it ends up that it's really helpful if the fiducial marker is always in the same place. For the user, it helps them. They don't have to think, where am I going to put this thing? Always put it to the left side. For the classifier, it helps it that always can find it in the same place. But children, they don't know left and right, so we put the wristband on their left arm, and then that way they knew that they'd need to slap that down. Now, an important part about this study too, we did not involve the parents, because we actually didn't know how much could the children do. And so that way we can find out from the children their level, their capacity, and then we can use that to help better guide the parents. So we haven't gotten to that part yet. Oh, so how old is this participant? No, they probably threw it out. Okay, someone said 4. So this one's 9 years old. Okay, so with this study, we did it in 2 samples. With the first sample, the children, they had the device only for 6 to 8 hours. There were 1 to 4 opportunities. They were in a child care setting to take the image pairs. And so that was but they kept it. We wanted to keep it, to have them keep it for a little bit of time as possible. And then we gave them a brief questionnaire, usability, acceptability, and willingness to carry around that fiducial marker. The second sample, we did 2 days, so that was 24 hours, and then 2 days, 4 weeks later, and they had a little carrying case and a charger. And then then the trained analyst reviewed the images with them afterward. For the reason that you really do have to go through and find out about the opaque containers, the opaque drink glasses, and things that you wouldn't be able to see. So then the first sample one, for including the fiducial marker in the image, around 70%. For including all the food, though, close to 100%. And then for including both, about 70%. So that was our first time with giving instruction, and not bad, really. The other important part was all the devices came back undamaged. And that was a big deal. And I think they might take better care of them than adults. Then their feedback was the mobile food record was easy to use. That's pretty high, as was borrow and use the mobile food record. But here's the really fun one. It's funner to carry this thing around than to carry around that mobile device. That's what's amazing to me. And actually, this isn't unique to just this population. Then this one that goes over 2 days and over 2 time periods, what you can see here is definitely we'll need to be getting the parents involved, because right here, these younger ones, they just had really a hard time remembering getting it all together. But once you get up to here, they then go even beyond 2 days. And then the second time around, we really would have had to have included the parents in here, so good to know. And then you can see that the range of these are the eating occasions. The range of eating occasions is quite wide. But at least we have pinpointed now where the ages are, what we need to discuss, what we need to go over, how we can best direct the parents. And that's a next step. We have not done that yet. But we'll at least have it tailored. So moving on now to passive. This is the study that's actually a part of here is not the one I'm going to go over. This one is on adults, but I am going to go over one that has been done on children with the E button. And this was published by Beltram et al. And the goal here was to adapt the E button for use by children, and that requires some understanding and finding out first, just like we had done. And so they did a study 1, and then 2 formative studies they conducted using this E button with children, and that's an example of the E button. There are other, just like there are other apps that are run on a mobile device, there are other button type items too. And this is the one that was developed by Mingei Sun, and there's a poster out there on this particular one. So study 1, 21 children, 8 to 13 years, tested 2 button weights. So there were 2 button weights that they tested, and then used that with just 1 meal sitting down. They could freely select 18 foods, and then each child was asked, would you wear the E button for 2 to 3 days at a time? Any concerns? And also the parents were asked about that too. So here's sort of the summary of everything that happened, but I think the things to zero in on is there were some identified concerns, but really half of the children, they said they would wear the E button during a meal. It was comfortable, had no problems, and they were fine to wear it for 2 to 3 days. Probably there were more concerns over here on the parent side, out of the 21 or 16, I guess, that they were falls, being concerned about attracting attention. So it is interesting that the children, and probably the next generation of children, will have different viewpoints than their parents. So the second study, it was 10 children, 8 to 13 years old. No siblings were involved this time. And each child was asked to wear an E button 1 day at home and school. So now they're wearing this E button for 1 day. There was a little bit of mechanics that needed to take place to make sure it wouldn't flop around, and they had to wear a special T-shirt, and they had to tape the button down. I think that was under the shirt. So here's how many over that. So that's 10 children over 1 day. And here are the number of counts of foods. These were the ones that were verified on the E button, and then these came in from the children. And the correct placement to obtain the image, 61% had correct placement to obtain the image. And then they had complete meals and snacks for 5 of the children, missing a dinner picture, missing lunch and dinner pictures. I'll have to find out. I didn't read how that was classified. You know, I suppose it was a timestamp thing. And then this was the feedback. It's kind of fun because on desirable, 3 children felt uncomfortable and 3 thought it really rocked that people paid attention to it. And then, but the biggest thing happened to be the battery running out or suddenly stopping or forgetting to turn it back on, because you can turn it off and then forgetting. So that really was the major issue. But with regard to wearing this, half of the children said, yeah, I could wear it during the day, and none anticipated about half of them wearing it for 2 to 3 days. And so in this particular group, the parents really didn't have the same number of concerns as that first group, other than these really were speaking to the burden on the parent, because they have to download the images and they take about 30 minutes. And then their one concerns were the unwanted attention, child distraction. But it's actually promising that young people would be willing to wear this. So now in the discussion, it's interesting with this discussion. What I found really interesting is that the threads through here end up highlighting that all these methods share the same problems. So we have here, the E button was able to be used by these children, but some children turned off the camera and forgot to turn it back on. In the discussion, it said smartphones, those methods require that picture taking be voluntarily initiated before and after the meal. Those are kind of the same problems. And then the lighting made it challenging to see some images. The camera has to be at a right angle in order to get proper lighting, but it's actually in order to get proper angle. So same thing. It's amazing. Here are these 2 methods, and they're all displaying the same type of thing. Some children want to stand, and that could be a problem over here, but it wasn't documented. Minimal necessary heights were identified to obtain images from a camera placed in a child's chest. So they had to do some, placement of it. Well, what goes along with that, a fiducial marker needs to be properly displayed in the image, all of which may pose problems for children. And so, which brings up my next image. How old is this child? Just shout it out. 4, very good. This child's 3 years old. 3 years old. So we don't really need to pinpoint the fiducial marker, but that's fine. The battery lasted only 9 hours, so some of the meals were missed. And then smartphones required voluntary picture taking. I brought that up again because that's one of the biggest downfalls. So it's really fascinating to me that here we have these methods entirely different, but we do share the same problems. And I think what actually we should probably redirect our energies to is which one works the best for this situation. Actually, we probably don't want to narrow ourselves down to only having one system. We probably want to have multiple systems and have them work with different, either different studies, different age groups, different cultures. So I think from this point of view, I really appreciate now that it's an issue of finding the best for the task. So then here, the promise of it, because this is interesting, the promise of these were supposed to say, hey, we'd have all the food for the day. But, you still need input from the child from the opaque foods for even when you're using the video, and then to identify missing foods. So when they turn it off, there's missing foods too. So we're just sharing all of these. And so every method that's doing images at this point in time needs to have some kind of review process in it. And that review process can be a trained analyst with or without the participant. It can be automated, and then the participant review do that review with a following trained analyst, or a trained analyst do it with or without the participant. But at this point in time, some method like this has to be incorporated in any of these methods if you do indeed want to try to collect as much food and beverage information as possible. This is an example of a trained analyst filling out. That's my timer to go off. Okay. So filling out this in order to and then that will set her up for talking to the participant. And then usually you have to go over about 2 or 3 things. Just as a little piece of information, individuals are they really like looking at images and pointing out what it is. We haven't had any pushback at all. Now this process takes about 30 minutes to an hour to do 4 days. This was 4 days, and then sitting here with the person and entering the data. The approximate duration for the staff processing of the images for 1 day for one child with the E button was about 9 hours, because it's big data. It's big data. But that's going to go away. That's going to go away eventually. So with regard to children, here's that sketch that I showed you at the very beginning, and all of these have the merit of being able to be adapted to children. And I think that's our big takeaway today. And I want to thank all the people that I work with. And then as the next person comes up, I grabbed this after our last speaker. This is food that we just took from 2 studies, because we could find food in every hour of the day. Thank you.